All right, our final section of college algebra, we're going to talk about sequences and series. And if you'll notice, they're in alphabetical order. SEQ comes before SER. I have to know the sequence before I can do the series. So a sequence is just a collection of numbers that's generated by following a pattern or a formula. And we usually say that the element of the series is n. So I want the nth term. So as soon as I know a formula for it, I could say if I wanted the 15th term, then you evaluate it at 15. If I want the 35th term, I evaluated it at 35, okay? But the variable that we use is an n. For series, the variables that we use are usually i's, okay? And the series simply means we add it all up once we know the answer. So I'm going to go through your homework in order, although it's going to be randomized when you get to it. But I'm going to do sequences first, and then we're going to hit series. So the first one says, determine the first 5 terms of the sequence given by the following formula, or whose nth term is defined as follows. So I have a sub n equals 9n plus 4. And it says give me the first 5 terms. So 1 term, 2 term, 3 term, 4 term, 5 term. Okay. So if I want the first 5 terms, that means if I want term number 1, I shove in a 1 here. So that means I've got a 9 times 1 plus 4. So 9 times 1 plus 4 is 13. If I want the second term, I shove in a 2. So 9 times 2 plus 4 is going to be what? 22. If I want the third term, you shove in a 3. So 9 times 3 plus 4 is going to be 31. And then 9 times 4 plus 4 is 3640. And then 9 times 5 plus 4 is 49. Now the benefit is you should be able to see these just increase by 9. So as soon as you know your starting point, 13 plus 9 plus 9 plus 9 plus 9. So as long as you're secure in the pattern, you don't have to do the math underneath it. But that's the sequence. If I asked you for the series, you would just add those 5 numbers together. Okay, so let's do another one. We have find the first 5 terms of the following. So a sub n is going to equal n plus 3 times n minus 3 times n minus 2. And I want the first 5 terms. So term number 1, 2, 3, 4, 5. So if I want term number 1, I'm going to shove in a 1. So I get 1 plus 3 is 4. 1 minus 3 is negative 2. 1 minus 2 is negative 1. So 4 times 2 is 8. Okay. I want the second term. So shove in a 2. 2 plus 3 is 5. 2 minus 3 is negative 2. 2 minus 2 is 0. Okay, so the whole thing just went to 0, which is fine. I want the third term. So 3 plus 3 is 6. 3 minus 3 is 0. 3 minus 2 is 1. That goes to 0 as well. That's okay. Keep going. I want the fourth term. 4 plus 3 is 7. 4 minus 3 is 1. 4 minus 2 is 2. And that gives me a 14. And the fifth term, shove in a 5. So 5 plus 3 is 8. 5 minus 3 is 2. 5 minus 2 is 3. And I get a 40. So that one, there was really no distinguishable pattern, so you had to do all the math anyway. All right, so now let's work backwards. What if I give you some terms? And I'm going to give you a hint. For the ones that we're working through, work with powers, okay? So like, see if they're squares, see if they're cubes, see if there's something like that. So I pretty much gave you just some easy ones. And then I'm going to use this one to translate this into summation notation. So what I have is, I got a 16. Well, what do we know about 16? I don't know. We got a 25, we got a 36, we got a 121. Well, one of the things that I notice is that 16 is 4 squared. Okay, 25 is 5 squared. 36 is 6 squared. This means keep going, okay, until I get to 121. Well, 121 is 11 squared. So I know what my pattern is, okay? So if I want to start filling this in, what I could do is say that these terms are a sub n equals, and then I would just say n squared, okay, because it's the value of the term squared. And I would have to explain in my instructions to start with term number 4 and stop with term number 11, okay? Now, what we're going to do is translate this into summation notation. So I'm going to use i's instead of n's. And then there's going to be this big Greek letter that's called sigma. Underneath it tells me where to start. So we already said we're going to start with the 4th term. So I'm going to start with I is 4. And then where do we keep going out to? We keep going out to the 11th term, so that goes on top. And then what's my formula? Well, instead of n squared, I'm using i's. So use I squared. This is not the I of imaginary number land. So don't fall into that trap, because it's not. All right, so my answer to this, though, is this is summation notation. So all I'm going to do is say 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared plus 11 squared. Now, there are some formulas that you could use, but for our intents and purposes, and because it's the end of the semester and everybody has coronavirus, we're going to keep this pretty basic. So when I add all these up across, you can see, oh, there you kind of can see, not really. I get 492. All right, so my answer to this would be a 492. So if it's summation or sigma or a series, you add them all up. If it's a sequence, then you just use n's, okay? So let's try another one. We have find a possible formula. Hang on. All right, so let's do this one. We just want to find a formula for the nth term. So I'm going to finish off the sequences, and then we'll go back to the series. So what do I notice is the same? Well, I notice that everything has a 1. So I bet 1 in my numerator is part of my formula. And this is given to me as the first 5 terms of the sequence. Well, how do I generate? Remember, I could write that over 1. How do I generate a 1 using 1s? How do I generate a 4 using 2s? Because that's the second term. How do I generate a 9 using 3s? Well, that's going to be the square of the value of the term. In other words, I know that the 6th term is going to be 1 over 6 squared, or 1 over 36. So you just kind of sort of have to figure it out and kind of play with it. So this one, well, your numerator this time is changing. And on the first term, it's a 1. On the second term, it's a 2. On the third term, it's a 3. So the value of the term is your numerator all day long. Well, then how do I get from a 1 to a 2? How do I get from a 2 to a 3? How do I get from a 3 to a 4? I take what's in my numerator and I add 1 to it. Okay, so that's your formula for the general nth term. So if I wanted to know what the 100th term is, it's 100 over 101. All right, and then what's this last one? We're going to go back and do this into summation notation again. So this is a 4, an 8, a 16, a 256. Well, I know that 4 is a perfect square, 16 is a perfect square, and 256 is a perfect square, but 8's not. So what I'm going to do is go back a little bit further. Well, what do I know? I know that 4 is 2 squared, okay? I know that 8 is 2 to the 3rd. I know that 16 is 2 to the 4th. So that's what I meant when I said, you know, try some patterns here. 2 to the 5th is 32. 2 to the 6th is 64. 2 to the 7th is 128. And 2 to the 8th is 256. Okay? So you just kind of sort of got to play with it and go out. Now, tell me where did I start? So my answer is going to be, the way I read this is the sum, starting from, well, what is changing? My exponents are changing, and I started with a 2. I ended with an 8. What's the same the whole time? The base is a 2. And then what changes is my exponent. So now the answer is just add all of those together. So when I add up those numbers, I end up with, I end up with 508. So my answer on this one is 508, and you'll have to enter that part in as well. All right, so let's backtrack and make sure we understand how to do these. So again, there are forms and formulas that you could use, but I'm not showing those to you because I gave you one small enough that we can just figure it out by hand. So this says start with the third term, go out to the seventh term. So term number 3, so I'm going to go 3, 4, 5, 6, 7. Okay, so all right, so we're going to start with term number 3. So 2 times 3 is 6, plus 3 is 9. Now go to 4. 2 times 4 is 8, plus 3 is 11. Go to, so we did 3, we did 4, go to 5. 2 times 5 plus 3 is 13. 2 times 6 plus 3 is 15. 2 times 7 plus 3 is 18, or 17, sorry. And that's where I stop with the 7. So now I just need to add these up. So this is 20, this is 35, this is 45, 55, 65. So I end up with an answer of 65. Okay, so let's do this one. Everything is going to be negative. So I'm going to square, I'm going to go from 1 to 5, I'm going to square everything and then make it negative. So that is not a negative I squared. Okay, the square only belongs to the I, then you change the sign. So I'm going to start with a 1, and I'm going to move out to a 5. So 1 squared is 1. 2 squared is 2. No, it's not. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. But that negative belongs to everything. So this gives me -1 and -4 is -5. That gives me -30. That gives me -40, -46, -55 is what that should be. Is -55. And then finally the last one, I'm just going to go 5, 6, 7. So I only need 3 terms. So 5 plus 2 is 7. 5 minus 4 is 1. So the first term I generate is a 7. Go to 6. 6 plus 2 is 8. 6 minus 4 is 2, which gives me 16. And then go to 7. 7 plus 2 is 9. 7 minus 4 is 3, and that gives me 27. So 7 and 27 is 34, 44, 60. Right? 50. All right, so that's how you do that. You just generate the term and then add them up together. The bottom number tells you what term to start with, and the top number tells you what term to end with, and that is college algebra.